On October 20th, 2025, one photo from a backyard observatory in Chile broke every rule of comet physics. Is 3I Atlas will vanish behind the sun, and if it's real, what it means could rewrite what we know about interstellar visitors. The coordinates matched NASA's track. The metadata checked out. The rig? A 150mm refractor with a narrowband H-alpha filter and a cooled CMOS camera built for solar flares, not comets. Yet it caught a geometry that shouldn't exist, if sunlight and the solar wind are doing their usual work. If this isn't an artifact and multiple independent reductions say it isn't, then the clock to perihelion just got louder. 8 days to the furnace. 8 days to find out whether we're looking at exotic natural physics or something built to work with starlight instead of fighting it. Before we go deeper, do this. If you care about real receipts over rumors, subscribe, like this video and tap the bell. Because when 3I Atlas reappears, we'll have the recovery frames, not the hot takes. Here's why urgency is justified. 3I Atlas isn't a routine snowball. JWST's early spectra flagged a carbon dioxide-heavy coma and anomalous metals nickel lines without iron numbers that already pushed comet chemistry off the familiar map. That's on record. And when the sun hammered Atlas with a monstrous CME earlier in the season, the story didn't get simpler. Some streams reported a tail loss, brightness shifts, and energy surges that forced modelers to reconsider what the solar environment can do to an interstellar visitor under extreme stress. The big idea: we're learning in real time whether this object plays by comet rules or writes new ones. The jet pointed sunward is our opening move. The endgame sits behind the sun, where Earth goes blind and only a handful of spacecraft can watch. Comets are simple storytellers, or so we thought. Sunlight hits ices sublimate, gas and dust. Stream off, shaping a fuzzy coma and two tails. The broad dust tail, pushed by radiation pressure, and the straight ion tail swept by the solar wind. Both point away from the sun. Even when geometry tricks our eyes, when Earth crosses a comet's orbital plane and an anti-tail appears to point sunward, that apparent blade is broad and sheet-like, not a collimated lance. Which is why that Chile frame hits so hard. The coma is weirdly tame. The feature is thin, coherent, and aligned with solar coordinates, exactly what artifacts tend not to do across multiple stacks. Could volatile chemistry fake it? Atlas has already teased us with CO2-dominated activity and an HCN-spiced coma. Unusual ices can vent from sun-facing fractures and produce narrow plumes. But volatile jets don't explain what's missing: a robust anti-solar structure. Even CO2-rich comets still grow tails. The other usual culprits, hot pixels, readout streaks, internal reflections, fall apart under calibration. Different observers ran different flats, darks, and stacks. The jet persisted. That moves this from quirk to claim that demands replication. Why does a single line matter? Because Atlas already violated the narrative months earlier. The CO2-H2O ratio near 8:1 and nickel without iron are not comfort numbers. They force new baselines. Receipts exist. Now add the sun's own violence. Reports of a massive CME lining up with Atlas's track. A shock that stripped a tail and left dynamics in its wake. Whether you read that as extreme space weather or stress test, it's a boundary condition we almost never get. And this is where the fear creeps in, not of danger, but of ignorance. A sunward jet says the rulebook has a missing chapter. The next pages are written at perihelion. Every extraordinary claim earns its bruises. So we run the gauntlet. Geometry first, anti-tails. Earth was close, but not perfectly in Atlas's plane. Strong anti-tails are broad dust sheets, not needle-thin beams. Strike 1. Activity cycles. Short-lived, sun-facing jets do happen when a fresh volatile seam vents, but they flicker and drift. The Chile feature lasted across hours and independent stacks. Strike 2. Atmospherics. Sub-arc-second seeing, round stars, precise tracking. If the jet were a smear, the stars would smear too. They don't. Strike 3. Chemistry. JWST's receipts keep biting: CO2 outpacing water dramatically, cyanide in play, nickel lines where iron should be louder. That cocktail supports weird jet, but not no tail. It's a puzzle, not a pass. Replication. Synthetic data, alternative kernels, different bias, flat, dark sets, no one's conjured a sunward spear by accident. As comet physicist Jonah Lowe put it, we've seen anti-tails, and we've seen transient jets. We haven't seen this exact trio collimated, sun-pointing, persistent, without the companion tail. That doesn't crown a new physics, it sets a trap for sloppy explanations. Meanwhile, the macro story keeps tightening. Atlas is interstellar, hyperbolic, fast, bright, and its chemical fingerprints bend expectations. JWST's spectra are the anchor for the CO2 and metal anomalies. They're not forum gossip. Pair that with the sun's earlier blast, where reports tracked a historic CME in Atlas's path, and you've got a test chamber few comets survive unchanged. The conservative read, a highly porous, CO2-rich nucleus with odd venting, caught at a wicked geometry during a bad solar week. The impolite question, why does the evidence keep stacking in the corner of not normal? We don't crown mysteries, we measure them. And the next measurement window is brutal and beautiful inside the sun's glare, where Earth can't look at all. Here's the knife twist. At the exact moment 3I Atlas is most likely to reveal its true nature, perihelion, Earth goes blind. Solar elongation limits slam shut every ground-based mirror. Even Hubble and JWST are hard-coded not to risk a glance too close to the sun. That leaves a tiny cadre of solar-first assets. SOHO's LASCO coronagraph can catch big outbursts or fragment trains on the limb. Parker's solar probe, if geometry and telemetry cooperate, they can log high-cadence brightness swings or scatter unusual particles across its detectors. They're imperfect, delayed, and filtered for solar safety, but they're eyes we desperately need. We've already seen how unforgiving this environment can be. Earlier this season, that historic CME barreled down the inner system, with model tracks lining up uncomfortably close to Atlas's course and reports that a tail was stripped. Whatever you make of those frames, it's a reminder space weather can erase signatures as easily as it paints them. Receipts for the CME narrative exist in public docs and videos. Explosive energy, extreme speed, a shock that would challenge any comet's envelope. So what do we watch for after conjunction breaks? 3 things. Photometry. A sudden post-perihelion jump screams outburst or breakup. Flat or fading brightness without tail growth is weirder still. Morphology. Does a classic anti-solar tail appear, or do we see that sun-pointing lance again? Astrometry. Tiny course changes tell big stories about forces we didn't model. And yes, there's a darker curiosity humming in the background Oberth window speculation. At 68 km per second, any deliberate push at perihelion multiplies. A modest retrograde impulse becomes a dramatic energy change. Nature can't time a burn, machines can. That's not a claim, it's a falsifiable test. If the outbound path shows a sudden step-like velocity drop beyond what outgassing can do, we'll see it in December's residuals. If not, the natural models get a win. Either way, the data get the final word. Chemistry keeps whispering. JWST's early reads didn't gently nudge the curve, they flipped it. A coma where CO2 swamps, water and nickel shows without iron's usual chorus. That's rare among comets, interstellar or otherwise, and it forces uncomfortable comparisons. Industrial processes on Earth isolate nickel from iron. Nature, with silicate dust and chondritic ratios, usually doesn't. These aren't tabloids, they're instrument logs. Then stack the dynamical oddities. A retrograde, nearly ecliptic skimming approach that maximizes solar leverage. A speed profile that invites an Oberth test. And now a collimated sunward jet captured in the wild by a rig built for flares. Strange single events can be hand-waved. Patterns are harder to dismiss. Pushback is healthy. Nickel without iron needs repeated confirmation. CO2. Heavy comet have natural origin paths. The sunward jet could still be a transient vent, plus projection plus processing convergence. Good. Science advances on the backs of tough null results. But here, the nulls keep missing. One more uncomfortable thread. Extreme solar events already seem to have interacted with Atlas. Reports of a massive CME striking its path and altering its visible envelope aren't just drama. They tell us what the environment can erase, reveal, or rearrange, and why this perihelion is a once-per-generation lab. If a forward-facing jet is real, Engineers have a name for such things in high-flux regimes, thermal shields and sun scoops that manage heat and attitude. That's speculation, not conclusion, but the signature we'd look for is a stable, aligned feature that persists and realigns as geometry changes. Nature has counters: porous shells, volatile patches, non-water drivers. We'll test them by watching whether Atlas returns with a normal anti-solar dress or that same spear aimed back at the light. JWST gave us the chemistry. The sky will give us the verdict. Let's talk receipts and thresholds, what would actually change minds. After conjunction, astrometry gets ruthless. If Atlas's outbound ephemeris diverges with a step incompatible with standard non-gravitational comet terms, we log it. If fragments appear, we measure their divergent speeds. Debris fields spread meters per second, growing separations, chaotic fans. Formation holds fixed geometry, near constant spacing. Synchronized motion would be the red flag that turns curiosity into a claim. Spectra. Do the elusive CO2 bands show up to justify any green seen in broad filters? Does CN rise or fade? Do those nickel lines keep whispering without iron's echo? We need high SN, multiple nights, matched reductions. Polarimetry. Dust grain physics can betray surface structure. Radar, thermal inertia, if achievable, can hint at hollowness or extreme porosity. The light but bright paradox some have raised big photometric mass with minimal gravitational signatures would be consistent with a shell. Or with fluffy ice. The data will tell. Meanwhile, the solar weather chapter matters because we have precedent, documentation of a ferocious CME, instrument spikes, and narratives of tail loss. Even if some of those details get walked back, the energy budget of that event alone places Atlas inside the hurricane. That means post-perihelion changes might be weather. Not will a vital distinction we can only make by comparing independent teams' reductions and calling out artifacts fast. The promise here isn't drama, it's method. If Atlas reappears with a textbook anti-solar tail and a quiet light curve, the skeptic case strengthens. If it emerges with that same sunward spear, a flat or fading post-perihelion brightness, and a path that kinks when models say it shouldn't, the conversation turns. Either way, we win. The sky answers. Zoom back to the human story. A lone observer in Chile posts a raw frame that pokes the bear. Forums ignite. Professionals quietly pull time on coronagraph archives and solar-side assets. And the rest of us watch the countdown to a window where only 2 or 3 instruments can see anything at all. Soho's Lasco can catch a dramatic shatter. Parker might sniff a brightness, flutter, or dust signature if geometry smiles. It's thin coverage, but it's all we get until November dawns and Atlas slides back into view. The wider context refuses to be quiet. Earlier season reports stitch a tapestry of extremes. A colossal CME directed along Atlas's path, claims of tail loss, and whispers that brightness and morphology were not following the script. Those aren't conclusions. They are invitations to measure. But they're not fiction either. The solar event receipts exist. Meanwhile, JWST's chemical shock remains the most sober, stubborn piece of this story. A CO2-dominated coma and nickel lines without iron, logged by a flagship observatory. That's the baseline everyone must address, natural or not. So we set the rules of the game. December recovery. Light curves, shapes, and orbits. Independent reductions only. Calibration logs attached. Artifacts named and purged. And if that sunward lance returns aligned, collimated, persistent, then the burden shifts. Not to prove aliens, to prove ordinary physics can do extraordinary choreography under the Sunday. We don't need to wish for weird, we need to be ready if weird insists. Here's the quiet, unsettling summary before the sky goes bright again. We have a raw, documented observation of a jet aligned toward the sun when the playbook says tails point away. The usual escape hatch's projection, bad seeing, artifacts are narrowed by clean logs and reproducibility across stacks. We have chemistry from JWST that is not business as usual. CO2 towering over H2O, nickel lines whispering where iron should sing. Receipts in hand. We have a recent season framed by extreme solar weather, with a colossal CME tagging Atlas's corridor evidence that the environment itself is turned to 11. And in 8 days, Atlas dives through an Oberth-rich perihelion while Earth's telescopes are forced to look away. That's not conspiracy, it's geometry and safety protocols. What would change everything? A step-like outbound velocity drop too large for outgassing, a reappearing collimated sunward feature after the furnace, a debris field that flies in formation instead of drifting like dust. Each is testable, each will be measured. Until then, we keep our promises. No sensational leaps, no hand-waving away hard anomalies. When Atlas clears the sun, we'll be here with the frames, the plots, and the math. If ordinary physics wins, we'll show it. If the data refuse to fit, we'll say so. If you want the recovery images, the light curves, and the astrometry residuals the moment they drop, you know what to do. The next 8 days are a razor's edge. Whether 3I Atlas is a porous wanderer with strange ices, or something that uses starlight with intention, the truth is close and the sun, as always, keeps its own counsel. So, what exactly is 3I Atlas? A natural wanderer defying physics or something designed to work with sunlight itself? Subscribe and like this channel and tap the bell. Because when 3I Atlas reappears after the sun's glare, we'll have the real images, not the rumors.